Many thanks to my awesome patrons and fine tool partners. If you're looking for some free stuff and want some early access, consider becoming a patron today. Rheostats and conveyor motors and drum sanders, oh my! Hey guys, what's up? Hope you're having an awesome day. Sorry it's been a little while since my last video, but I intended to make this video a lot shorter, or sooner I should say, than it really was. But I had a problem with my drum sander. I have an 18 by 36 Delta drum sander. Don't ask me the model number offhand, I don't know it. But the conveyor belt motor just let out its magic smoke, and I had to replace that motor. But I ran into some other problems along the way, and you're gonna find out what those problems were and how we fixed them. So if this is your first time here, I want to welcome you. Please don't forget, if you like videos like this or any other videos that I make, don't forget to hit that subscribe button, click that notification bell, and it'll tell you anytime I upload brand new content. If you want to leave me a comment, tip, or suggestion down below, feel free to do so. And anything that I did in this video, parts-wise, you'll find links down in the description. Don't forget, if you want to also become a patron of the show and help support the channel so I can bring you more and more content as often as possible, you can check the links down below. Now, to get this motor off, there are 4 screws, 2 on top and then 2 on bottom directly underneath in the same locations, that hold a 2-piece bracket and the motor onto the whole unit. Up inside this opening right here on the side though, there's something we need to address before taking out this final screw. If you look up inside the bracket opening here, you'll notice on the shaft there is a jam screw right there that holds the actual pulley system of the in-feed belt, and out-feed belt rather, to the motor itself. And we need to loosen that jam screw in order for the shaft of the motor to slide out. Whew, almost hit the camera. Okay, so there it is. It's just a small little short shaft that comes out through the bracket and goes right into that hole right there for the pulley system for the in-feed and out-feed rollers, and then that jam screw is right there. So once you have everything loose, it should just come right off. So this half of the C-channel bracket that attaches to the motor we need to take off so we can bolt this motor up. So there's just 4 holes that should line up just right if you bought the right motor, which we did. So using another Allen wrench, we're going to take these 4 bolts out. Now, just looking at the original motor, which is this one here, and the new motor, this one here, you can see that they are identical. Now, on the original motor, there came a plug that plugged into the other half that went to the sander itself. I did have to connect wires from the new motor to this particular plug, and I'm going to do that exact same thing again. Okay, I've slid the motor back into place, and the jam screw is actually facing the machine right now, because that's how it was aligned whenever I got the motor, so I had to make sure that it was aligned the same way. So I'm going to reach inside here with the Allen screw and tighten it back up on that shaft. And I'll go ahead and put these 4 screws in on the C-channel to mount it back to the machine so I can start with the electrical. All right, now this is the original plug that goes into the machine, and this is the plug that I cut off the old motor. I'm gonna go ahead, without the connectors on, install that plug in place just like if it was installed already. Now, leaving these wires completely separated just like that to where they won't touch, we have to use them to find out what direction we need to hook up these wires from the motor and make sure that the belt turns in the direction that we want. Okay, with the machine plugged up and my rheostat for the conveyor belt turned on, and these 2 wires separated quite a bit from each other so they don't touch, we're going to touch 1 wire per side at the same time to see what direction the conveyor belt goes. And if it starts feeding where this is the outfeed and it starts going that way, then I'm going to take a piece of tape that I have right here and mark one of these to the corresponding red wire, so I know that whenever I go to hook it up, the tape goes to the red. So I got them exposed. Just gonna touch one. So I've ran into a little bit of a situation. If you guys noticed, whenever I was touching the two wires of the motor to the two wires that were in the DC plug coming out of the back of the unit, nothing happened. So it kind of led me to believe there might be a problem with the rheostat in the control box, because I can flip the main switch, which controls the drum, and it comes on. And I've never had to have the two on for one of them to, or both of them to work. You can turn them on independently. So I know that there's power coming to the drum, so I needed to find out if there was power coming to the rheostat. After checking with my voltmeter, I was able to find that the power cord coming to the rheostat had 120 volts to it. So there is power getting to it, but it's losing contact somewhere between where the power comes in and where it goes out. So I was checking some of these resistors that are here on the inside of the plate or the board, and found one resistor that didn't give me any kind of reading on the ohm meter, so that needs replaced. So I'm gonna have to send this thing off, because unfortunately this thing isn't manufactured anymore. So another minor setback, but it's something that you guys can come in contact with possibly if this happens to you and know how to fix it. All right, so it's been a few days and there's been some developments. My brother received the old rheostat that I sent him, and as it turns out, the two things that I was testing, which I thought were resistors, are actually diodes. So two diodes were actually bad. As it turns out, my brother found a number on the back side of the old rheostat, and it's a discontinued one. I can't get it anymore from E-plate replacement parts or anything. So he found another rheostat board that actually supplies a little bit more power. The old circuit board that came out of the unit was a 1 amp circuit board. This one is a 4 amp circuit board, and actually has two terminals on the back that are coated that I don't intend to use, and from what I've been told, this will still work just fine. So to protect this rheostat, what I intend to do is install an inline blade fuse between the motor and the rheostat, so if the motor ever locks up again from being put under constant load, it can't send an electrical current back to this, because it will have to go through that 2 amp fuse that I'm going to put in the way, and if it ever breaks it, all I gotta do is pull the fuse out, put a new one in, and replace the motor if I have to. So yeah, let's get this thing installed. So the way this works, the power cable that comes from the 120 volt source feeds into the main switch that controls the drum. There is a separate power wire that comes from that switch that feeds into this rheostat, which allows you to be able to turn the two on independently from each other. And once the rheostat is turned on, it basically inverts the power to DC from AC and powers the motor that runs the conveyor belt. There is another couple of terminals that basically feed the neutral wire from the rheostat back to the main switch that connects all the circuitry together. So the 4 terminals, the red and the black, are for the DC motor wires, and then the other 2 that are blue are for the 2 hot and neutral wires that come from the main switch that powers the motor, or that powers the big drum. Okay, so here are the wires. These are the 2 wires that come from the 120 volt source. This is the hot, this is the neutral, and then these are the 2 wires that feed DC current to the motor that's in the back of the unit for the conveyor belt system. And then the rest of it is all controlled at the switch that controls the drum. So like I said, these are 2 independently controlled units. So the neutral wire goes right here on this blue terminal in the middle. The hot wire goes to the black terminal, or blue terminal I should say, not black. The blue terminal on the side that's down low. The black, I'll do the red first. The red goes on the red terminal just next to the hot wire, and you see it's insulated to protect it. And then the black DC wire goes on the black terminal just above the hot wire. So it's kind of hard to see, but I'll give you a close-up. So that's the black wire from the motor, that's the red wire from the motor. They're both insulated. This is the hot wire that's behind it right there, and then this is the neutral wire going back to the main switch. Now with all that put back together, I'm just going to screw the casing back onto the unit. Okay, I've got the unit plugged back in, and we are going to do our test run. And as you've seen, I put the inline fuse on the hot wire side of the DC plug that runs to the motor. So now I've got a 3 amp protection circuit, so if this motor ever goes back to the rheostat, it'll blow this before blowing the rheostat. I've got a fully insulated male connector. I went ahead and just purchased some new ones because I was out. And I've got it barrel connected to the red wire on the plug itself. I've also got another fully insulated male connector here on the ground wire, or the black wire. And I'll put the corresponding females on the other wires from the motor, and I'll just offset these wires to offset the length of the inline fuse. I now have the plug plugged into the other plug, its adjacent plug, that comes out of the back of the unit. This is the plug side that actually attaches to the motor. However, we have not yet established which is a hot and which one is the ground wire for the DC motor. Now this can be polarized one or two ways, so it can go forward and it can go backward. This little piece of trash that I have sitting on top will be feeding towards me if I have it hooked up correctly. I have a camera set up over here that's simultaneously recording the in-feed and out-feed conveyor belt, so we'll do our test by holding the wires up against the connectors before attaching the female insulated connectors on these, and then we'll establish which one's the hot and which one's the ground. So I've got the unit plugged in. I'm going to turn on the rheostat about halfway, and I'm just going to hold the wires just kind of between my fingers so I can put these wires against the connectors, and we'll see which way they go. All right, this way the conveyor is going in reverse, so I'm going to swap them around. So it looks like our hot wire is this one right here. So what I'm going to do is put a piece of tape around it so I can not screw it up anymore. All right, so like I said, the drum operates by itself. Nothing wrong there. And here is the conveyor. It's alive! It's alive! So as you can see, this didn't quite go according to plan, but I did manage to get it working again, and we learned something new along the way. My brother taught me quite a bit in regards to this rheostat. He helped me find all the parts, so I want to thank him very much. He is the bomb. And the motor itself, I managed to get 2 of, so now I've got a backup in case this one blows out again, which I hope it doesn't. But I will leave links down in the description below of all the parts and where you can find them, so if you have a machine like this, you'll know how to fix it. Well, at least in that regard. So, hope you guys enjoyed this video. Please give me some comments and a thumbs up if you enjoyed it, and I guess I will talk to you on the next episode. Boom!